Welcome. We are the Nissan NextGen team, and here we design a full-scale reconfigurable buck for Nissan. This book will be used to compare existing vehicle configurations to give Nissan insight into the mind of the consumer and inform design choices for potentially the next generation of Nissan vehicles.
This vehicle buck was designed and built for use in Nissan North America's clinic research. It features 4 sets of pillars. The A pillars mark the front of the buck, the B pillars define the rear of the driver's area and the front of the rear passenger section, the C pillars represent the back of the rear passenger space, and the D pillars indicate the end of the cargo area and rear of the vehicle. The waistline is defined as the bottom edge of the windows or the top of the doors as seen in a typical passenger car. The design needed to accommodate a wide range of adjustability, including the overall width and length of the buck, the height of the waistline, the position of each pillar along the length of the buck, as well as the height and angle of each pillar above the waistline. Additionally, the 2 front seats and rear bench had to be adjustable in 3 axes. The entire structure also had to be compatible with Nissan trim pieces, such as doors, the instrument panel, pedals, and headliner, to ensure the interior appearance aligns with Nissan's design concepts.
Various types of pivot joints were used to achieve the required motion for adjusting the buck. Starting where the pillars meet the roof, perpendicular pivots were implemented on the B, C, and D pillars to allow rotation of the roof beams. Pivots were also installed at the waistline to coordinate the angle between the upper and lower pillars, referred to as the tumble home angle. On the A pillar, that tumble home pivot was coupled with another one to control the windshield angle. To accommodate larger vehicle configurations, we were required to include telescoping members with detents on each of the lower pillars, as well as the upper B, C, and D pillars. These telescoping members were milled from rectangular aluminum tubing and include PTFE bearings.
For the seats, we designed a mechanism using linear bearings to allow side-to-side and forward-to-backward adjustment. The main challenge was achieving vertical adjustability while keeping the design compact. To address this, we went through several iterations, removing wood components that separate each direction of movement, repositioning the mechanisms, and ultimately incorporating a scissor jack. This scissor jack provided vertical adjustability while supporting the weight of the seat and 1 or more occupants.
For the doors, we used lift-off hinges to enable quick and tool-free attachment and removal, allowing us to completely swap out the door panels for each new buck configuration. This flexibility ensures that the doors can perfectly match the size and geometry of different vehicle layouts. The hinges also allow for vertical adjustment along the A and B pillars, helping us align the door with varying pillar heights. To create a more realistic door profile, we constructed the doors using 2 aluminum extrusions attached perpendicularly using a T-flat plate, forming a simple but accurate representation of a vehicle door.
The floor plays a crucial role in supporting seat and overall buck adjustability. To enable lateral and longitudinal seat movement, we introduced a slit for both front and rear seats, which maintained structural integrity and did not interfere with other components of the buck. The floor was made with 3 interlocking plywood panels that accommodate front and rear seat mechanisms and are securely attached to the base of the buck, all while supporting multiple buck configurations.
Here we see a side-by-side comparison of the experience a clinic participant will have. On the left is a first-person view of a participant entering and sitting in the buck, while on the right is the view from an existing vehicle model. Participants will evaluate our buck against the existing model from various seating positions, assessing factors such as overall size, roominess, and interior spacing. And in the next clip, you'll see a real-time recording of a clinic participant assessing the buck.
To adjust the tumble home angle of the buck, we first loosened the angle pivots located at the top of each B, C, and D pillars, then repositioned the tumble home members to the desired angle using a mobile phone inclinometer. Once aligned, we securely fastened the pivots. After adjusting the tumble home angles of the B, C, and D pillars, we moved on to the A pillar. First, we set the tumble home angle to match the side profile of the vehicle. Then, we adjusted the upper pivot to tilt the A pillar inward towards the driver, simulating different windshield angles. For the telescoping pillars, we removed the existing pins from their detents and reinserted them into the new desired positions, ensuring that all 4 pillars were aligned at the same detent level for consistency. Following these waistline adjustments, the existing headliner no longer fit the updated geometry. To narrow the roof, we overlapped the 2 roof halves and secured them with zip ties. Finally, we remounted the modified headliner onto the newly configured buck.